Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about slopes of parallel lines. And so to begin we need to talk about the equations for lines. It was slope-intercept form, which is y equals b plus or minus mx. And in that equation we can say m is the slope of the line and b is the y-intercept of the line. And then we can say that parallel lines are in fact two lines that have the same slope. Or in other words, we can say that they will never touch each other. They'll just run right alongside of each other for forever. Now, if we look at a line in the coordinate plane, so in the red line here we have y equals negative 1/3 x plus 4. If we want a line that's going to be parallel to that line, we know that the slope of that line has to be negative 1/3. It has to be the same here as the slope of that line. So we could say, for example, if we wanted to have a line passing through this point and parallel to the red line, well, we could say it's going to have a slope of negative 1/3, so we can use that slope of negative 1/3 to find other points that are going to be along that line. So here we have the green line is a line that is parallel to the red line. And we can write that equation as y equals negative 1/3 x plus 0. And you don't necessarily have to write the plus 0 there, but if you like, you can. And we could do another line that's parallel to the red line. We could do a line that passes through the point here. Let's go negative 6 comma negative 2. So here the blue point is negative 6, negative 2. And if we want a line that is going to be parallel to the red line passing through that blue point, well, we just use the slope, which is negative 1/3, and we just keep plotting points to find out where that line's going to be. Okay? So the blue line, again, is going to be parallel to the red line, and the equation of that would be y equals negative 1/3 x, and then minus 2, 4. Okay? So here we have the directions for this next two equations are going to be write the equation of the line that is parallel to the given line and passing through the given point. So the original line here we can say is y equals 2x minus 1, and the new line that's going to be parallel to that is going to pass through the point negative 3, 0. So let's look at what that would look like on the graph here. The original line, y equals 2x minus 1, is the black line on the graph. And the new line is going to be parallel to that. So the new slope, the new line has a slope of 2, which is the slope of this line. And it's going to pass through the point negative 3, 0. So the point negative 3, 0 is here. So I'm going to use the slope then of 2 to find other points on that line. So I go up 2, right 1, up 2, right 1, up 2, right 1. And then I can just graph the equation there. And we can see it's parallel, obviously. And then the equation of that line would be y equals, well, it's 2x already, we know, because the slope has got to be 2. But then it's the y-intercept of that red line, which is going to be 2, 4, 6. So plus 6. So that would be a way to do part A for this problem. Let's look at part B. So in part B, we have the original line was y equals negative 2/3 x plus 5. And to graph that, we would put a dot here at 2, 4, 5, and then go down to right 3, down to right 3, and so on and so forth. So the black line here represents the equation y equals negative 2x plus 5. And then we knew the new line that is going to be passing through this red point here is going to have the same slope. If it's going to be parallel, it has to have the same slope, which is negative 2/3. And so we need to also plot the point negative 6, 1. So negative 2, 4, 6, 2, 4, 6, 1. So that's the point negative 6, 1. And then we use the slope to find other points. So you would go down to right 3, down to right 3, down to right 3, and just keep going. And then we could create that line. That's not a very straight line. And that would be a parallel line passing through the given point. So to write that equation of the line, we would say y equals negative 2/3 x, of course, because the slope has to be the same. And then our y-intercept is going to be negative 3, so minus 3 there. Now let's try two more problems, the same directions here. We're writing the equation of the line that's parallel to the given line and passing through the given point. However, here we're given points that the line is passing through that are much greater that we will not be able to graph on a line. So if we take part C here and we look at the graph, y equals negative 3x plus 2, that is the black line on this graph. And in order to graph the dot, which was 10, 22, we would have to go over 10 places to the right here and then go up 22 places. So our dot's going to be somewhere in this region here. But our graph's not big enough. And we could change the scale of the graph to make it work, but there's probably an easier way to do this. And we're going to use the equation, what we know the equation's going to be, to solve this. So here we know the original line was y equals negative 3x plus 2. And we know the new line is passing through the point 10, 22. So we also know, though, that the new line is going to have the same slope as the original. So we can say it's going to be negative 3x. And then we don't know what b is quite yet. So we're going to just leave b as a variable also. And if we look at that point that we're given, this is an x-coordinate and this is a y-coordinate that we can use to plug into the equation. X here and then y here. So you would say 22 equals negative 3 times 10 plus b, and then this would be 22 equals negative 30 plus b, and then we'd add 30 to both sides. And then here we would find out that b in fact equals 52. So that the new line, the new parallel line that we're going to write that equation is going to be y equals negative 3x, because it has the same slope, plus 52. And that would be your answer. And of course, we know that it'd be tough to find that if you were using a graph. It's a little bit too large here. The 52 is the y-intercept. Let's look at if we did part D. So in part D, we're given the original line was y equals 3/4 x. And there we can understand that the y-intercept was 0. And then we are given the new line is passing through the point negative 32, 18. So we also know, though, that the new line is going to have a slope of 3/4 as well. And then we're going to put plus b because we don't know what the new y-intercept is going to be. And again, so we know what x and y are in this equation. So we can just plug those in and use those to solve for b. And here, when you multiply the 3/4 and the negative 32, you're going to get negative 24 plus b equals 18. And then you're going to add 24 to both sides. And therefore, b is going to be equal to 42. Okay? Now, we're going to use that for the new equation, which will be y equals 3/4 x plus 42. And again, we could see that that is a very large y-intercept. We probably wouldn't be able to find that very quickly on the graph. And so this concludes our lesson on parallel lines.